Welcome to my video on the chain rule example. In this video, I want to find the derivative of the function y is equal to x divided by 3x plus 2, that whole quantity raised to the fifth power. So let me get started with the example. So we want to find the derivative of the function y is equal to x over 3x plus 2 raised to the fifth power. Now we're going to use our chain rule. There's other ways that we could do this. The extended power rule probably work on this too, but this is as good as any. And we just got through going over the chain rule, so we want to practice it a little bit more. So dy dx, and this is the Leibniz notation. As you saw in the previous video, there's more than one way to write the chain rule, and that could get a little bit confusing. So that's why I'm doing this example, is because it does get a little confusing. And then the kind of the hard part, or the tricky part sometimes when you're using the chain rule, is picking out what the u and the y functions are going to be. U is equal to x over 3x plus 2. That looks like a good choice. And then y is equal to u to the fifth. So let's make that choice for our u and y function. Now we know we're automatically going to need the derivative of this. So we're going to need du with respect to x. Now, we've got a ratio of two functions there, so we're going to need our reciprocal, or our quotient rule. So let's use our quotient rule. And basically what that tells us is the quotient rule for the derivative of a function is the denominator times the first derivative of the numerator minus the numerator times the first derivative of the denominator divided by the denominator squared. So there's our formula. Now in this case, let's just write that out. The denominator in this case of this function is going to be 3x plus 2. The derivative of the numerator is just derivative of x, that's just 1, minus the numerator, which is x, times the derivative of the 3x plus 2 is just 3. And then divided by the denominator squared, which is going to be the 3x plus 2 quantity squared. So let's see, that's working that out. That's 3x plus 2 minus 3x divided by 3x plus 2 quantity squared. The 3x's go away, and so that's just 2 times 3x plus 2 quantity squared. Now remember, that is going to be du dx. Okay, that's not the answer to the problem. That's just an intermediate step. And now the dy du is much simpler using the power rule here. That's going to be the derivative with respect to u of u to the fifth power. That's just 5u to the fourth power. So there's what we're going to need to continue this problem. Now we're going to put all that in and see what falls out. Now let's continue on with the example. What I'm going to do is copy the stuff from the first page to this page so that I don't make a mistake. It's really easy to do. I found it's better to just be neat and redundant sometimes so you know exactly what you're doing. So there was our u and there was our y, and then we calculated du dx is equal to 2 divided by the quantity 3x plus 2 quantity squared. That we did using the quotient rule, and then du or dy du is equal to 5u to the fourth. Okay, so there's what we know so far. Now in our chain rule, we've got to calculate dy dx is equal to dy du dy dx. There's our chain rule. So let's substitute those values in there. Okay, so the dy du is going to be 5u to the fourth power. That's our first term. Now the du dx is 2 divided by the quantity 3x plus 2 quantity squared. There's what we have now. We know the u is going to be this quantity right here. We can substitute that in there. So that's 5 times the quantity x divided by 3x plus 2 raised to the fourth power times 2 divided by 3x plus 2 quantity squared. So that's what we have now. We can factor out the 5 and the 10. We can take that out front so we get the 10. Now we can also factor out this x to the fourth and move it out front. So what we're left with now is we're 1 over 3x plus 2 quantity to the fourth, and then 1 over 3x plus 2 quantity squared. And really those are just, they put that in the denominator since 1 squared. So it's 10x to the fourth, and then that is going to be times 1 over 3x plus 2 to the sixth power now, because we're just combining these powers. So that can be written as 10x to the fourth divided by the quantity 3x plus 2 raised to the sixth power. So there is our answer. And that is the derivative of the original function y is equal to x plus 3x plus 2 to the fifth. Now, this is one of the problems with the chain rule. It gets a little complicated. Is this y started out to be the original function, but we've also used it as an intermediate in here. So you've got to be it's a little bit confusing. So be a little careful with that and keep your y straight, because I know it kind of changes form, and that's one of the warnings on the power rule using this notation.